North, south, east, and west. Our nation's economy rides on the big rigs, thousands of them, hauling everything from apples to space shuttles. We need the big rigs. We need them doing their jobs profitably and safely. That's where we come in. We're Midland Grau Heavy Duty Systems, a worldwide company. Brake reliability and safety is our business. That's why we produced this video, to help you understand air brake systems better, and to give you some practical tips on maintenance and troubleshooting to keep your big rigs stopping safely. Brake safety on heavy-duty trucks, tractors, and trailers is no longer an option. It's the law. To be exact, it's Federal Motor Vehicle Safety Standard Bill number 121. Since 1975, this law and its amendments have dictated the design and operating standards for heavy-duty vehicles with air brakes. Since the big rigs have to share the roads with passenger cars, they must have the safest and most efficient brake systems possible. The stakes of liability and maintenance costs are too high to neglect them. But operators are already using old trailers with new tractors, and new trailers with old tractors. So, for some time to come, technicians will be working on air brake systems that combine old and new technologies. The challenge is to make the old and new, the new and newer, work together efficiently and safely. That makes knowing the fundamentals of air brake systems more important than ever before, and that's precisely what we'll be covering in this video. As we do, we'll be using a generic type air brake system to demonstrate the fundamentals. We'll equip it with S-Cam foundation brakes, since this is what you're likely to see. Remember, however, to always consult the manufacturer's service manual for the specific system you're working on. Now let's get an overview of how an air brake system works. First, why use air to stop a big truck or tractor? Well, it's cheap, plentiful, and it works even when it leaks. The basic concept is simple. Put air under pressure until it's strong enough to make the brakes stop the vehicle's wheels. Here's how the system works. An air compressor is used to bring in the air, put it under pressure, and store it in a reservoir until it's needed. The air is sent from the reservoir through a foot valve to the brake chambers located at the wheels. In the brake chamber, the compressed air will push a rod, which, in turn, pushes a lever called a slack adjuster. The slack adjuster rotates the S-cam, forcing the brake shoes against the drum to slow and stop the wheel. That's a very simple overview of how an air brake system operates. But just as there are smaller circuits that make up the electrical system in a house, for example, there are 7 smaller circuits in an air brake system. Knowing these circuits and their devices will make it much easier to isolate the source of a problem when servicing or troubleshooting an air brake system. Let's review all 7 circuits. The air supply, the secondary service, the primary service, the parking circuit, the emergency circuit, the anti-compounding circuit, and the trailer supply and control circuit. Let's begin with the air supply. Circuit. The compressor is the heart of the whole air brake system. Without a good air supply, you won't have a good, well-functioning system. An air compressor is simply a pump. Its job is to supply all the air required by the brake system to stop the vehicle safely, and also for any brake-related accessories. The standard for years for tractor-trailer combinations has been 12 and 13 cubic feet compressors. But with today's double and triple trailer combinations, including some with air suspension, air liftable axles, air seats, and the new anti-skid systems which require more air, there is a real need for a more powerful heavy-duty compressor. The compressor does its job by taking in naturally aspirated air through a filter on its side, or directly from the large engine air filter. Some manufacturers force turbocharged air into the compressor directly from the engine turbocharger system. The air is then compressed for storage in the tanks or reservoirs. Compressors rotate continuously at engine speed and are either gear or belt driven. They are cooled by the engine coolant and lubricated by oil from the engine. Most compressor problems are related to air supply or oil flow. For example, complaints that the compressor pumps too slow or won't shut off are air-related. The problem is most likely to be the governor or the compressor unloader circuit. Check the governor cut-in and cut-out pressures. And finally, check the compressor unloader mechanism for possible cleaning and servicing. Other air trouble spots to check are discharge line restriction, carbon buildup in the discharge line, or possibly a plugged or restricted desiccant bag in your air dryer causing the pump to slow. The crucial question for oil-related complaints, such as the compressor is pumping too much oil, is how much oil is too much? Compressors are designed to pass small amounts of oil into the air system for lubrication purposes. However, it's very important that systems be drained every day to prevent oil accumulation. Oil pumping will be caused by a dirty intake filter or turbocharged system that starves the compressor of air while delivering air to the engine turbo. Excessive crankcase pressures, poor drainage, or excessive oil pressure also cause oil pumping. Now let's move on to other components in the air supply circuit. The air dryer, the supply tank, the pop-off valve, the automatic drain valve, the low-pressure switch, and the governor. The air dryer is located here. A good maintenance program will inspect and service the air dryer to eliminate dirty filters, desiccant contamination, and purge valve leakage. On those vehicles with air dryers and turbocharged air compressors, there will be an isolation valve. Its job is to prevent the loss of turbo boost pressure when the dryer purge valve is in an open position. This valve may be separate or built into the air dryer, as Midland does. Alcohol evaporators are sometimes used to reduce cold weather freeze-ups. These units are installed between the air dryer and the first supply or wet tank. Don't allow alcohol to enter the air dryer because it turns desiccant into mush and plugs the circuit. In the next step, compressed air flows to a supply tank, commonly called the wet tank. Its purpose is to collect the condensation and contaminants for removal. There is a drain valve on the wet tank to expel the collected water and contaminants. Manual drain valves are required by law, but automatic valves are permitted as well. Regardless of the style, draining the wet tank is the most important service for any air system and must be done at least daily. Another air supply circuit part is the safety valve, sometimes called a pop-off or pressure relief valve, that is preset to pop off at 150 psi. Also, there is a low-pressure switch in the wet tank that operates the light and buzzer when the system drops below 60 psi. The last component we'll examine in the air supply circuit is the governor. It's usually located on the side of the compressor. The governor is simply a switch that turns the air compressor on and off. It also controls items such as the air dryer purge valve. The governor is a spring-loaded valve that switches the compressor off at about 120 psi and back on again at 105 psi. At cutout pressure, the wet tank simply sends an air signal through the governor to the compressor unloader mechanism to hold open the inlet valves so the compressor can't pump. Troubleshoot the governor and unloader circuit together. Start with the governor by checking the cut-in and cut-out pressures. If they are operating correctly, the problem is likely in the unloader. That wraps up the overview of devices in the air supply circuit. Next, let's look at the basic components in the secondary service circuit. This is the circuit that stores compressed air and delivers it to the secondary circuit breaks which are usually the front wheel brakes. The parts of the secondary circuit that we'll review are the secondary service tank and one-way check valve, the drain valve, the instrument panel gauge, the dual foot control valve, the front brake quick release valve, the front service brake chambers, and the slack adjusters. Let's begin with the secondary service tank on the vehicle. The volume of all service tanks is dictated by Law 121 for service braking. Notice that the secondary air supply tank is isolated and separate from the primary air supply because 121 law requires split brake systems. There's a one-way check valve located in the tank. Its job is to permit air to flow from the wet tank into the secondary service tank, but at the same time prevent the air from bleeding back into the wet tank. The secondary supply tank must have a manual drain valve to permit condensation and contaminants to be released. The driver is aware of the tank pressure by reading the secondary tank gauge on the instrument panel. Here is the dual foot control valve. Its function is to modulate the application of the front service brakes by controlling the delivery of air to the service brake chambers. The dual foot valve also separates the secondary and primary circuits. Next, the stop lamp switch and two-way check valve combination. A two-way check valve is described as a T with a roller ball that seeks out the dominant pressure from two sources and delivers it, in this case, to a stop lamp switch. So on one side of the two-way check valve will be the secondary service brake application, and on the other will be the primary circuit. Another secondary circuit part is the front brake quick release valve. Its job is to release air pressure in the front brake service chambers quickly. On braking application, the quick release valve merely serves as a T connector through which air flows to the front service brake chambers. And when the foot valve is released, the air in the chambers is allowed to exhaust quickly out of the quick release valve rather than having to flow all the way back to the foot valve. Be careful when replacing quick release valves because some contain springs to create hold-off or differential pressure to balance the front brake with rear wheel or trailer brake systems. The secondary service circuit also includes a service brake chamber located at each front wheel. When air is applied to the service brake chamber diaphragm, it forces the pushrod to rotate the slack adjuster, which is the final component we'll see in the secondary service brake circuit. The slack adjuster is simply a lever that turns the S-cam in a rotary motion, forcing the brake shoes into the brake drum, thereby applying the front brakes. The slack adjuster also provides a means of adjusting the service brakes during maintenance. Now let's take a look at the primary circuit brakes during maintenance. Now let's take a look at the primary circuit which provides braking to the rear wheels. We'll find many similarities between it and the secondary service circuit. Yes, the primary service tank also has a one-way check valve that allows air from the wet tank to flow into the primary tank and prevents air from bleeding back into the wet tank. The one-way check valves on the primary and secondary service tanks also split the system and isolate each other so that air loss in one does not affect the other. The drain valve story is the same. It drains the tank, and the primary tank has a gauge dedicated for driver information. The primary circuit foot valve ports are always those closest to the treadle. Care should be taken when replacing the foot valve because differential pressures between the primary and secondary circuits might vary as much as 9 psi. These varying differential pressures are designed to assist in balancing the front and rear brakes. To upset this balance would result in poor brake lining life and an unsafe, inefficient system. When troubleshooting a leak at the foot valve, keep in mind that the foot valve is involved in the exhaust of air for the total air brake system, and therefore a leak at the foot valve might well indicate leaks in other parts of the brake system. What's different in the primary circuit? Basically, the spring brake assembly and the rear axle service relay valve. Let's learn about a relay valve, because to understand the operation of a relay valve, is to understand its major effect on the efficiency of the total brake system. First, a service relay valve is a modulated valve as opposed to an on-off valve. While there are many sizes and shapes, they all function the same. A relay valve is a balancing valve for brake application and release. Therefore, the location on the vehicle is critical. It relays the small volume modulated signal pressure from the foot valve to large volume delivery of similar pressures to the rear service brake chamber. The valve also incorporates very large exhaust ports for quick brake release. When replacing relay valves, be aware that they are designed to operate on a one-to-one basis, 20 psi in, 20 psi out. However, some truck manufacturers have springs installed under the application piston to assist the brake balance, springs that can take anywhere from 2 to 11 psi to overcome. Some technicians relate this to crack pressure or differential pressure, but whatever it's called, it is designed to balance the vehicle or the tractor-trailer combination and should not be upset. Therefore, be very careful to replace with the proper valve. A major troubleshooting complaint about relay valves is leaking at the exhaust port. Remember that a leak in the center seal of the spring brake assembly will exhaust out of the relay exhaust port. This is a major area of wear. The next primary circuit component is the spring brake assembly. There are two assemblies, one located at each rear wheel. The uniqueness of the spring brake assembly is that it provides service braking and parking capabilities from a single unit. There are two sections to a spring brake assembly. The front section is the service brake section, which operates like any other brake chamber. We'll deal with the spring side later with the parking circuit. Primary circuit air from the relay valve is now working on the chamber diaphragm, which moves the push rod and slack adjuster forward, rotating the S-cam, which forces the shoes into the brake drum. Midland experience dictates that the slack adjuster should rotate in the same direction as a forward rolling wheel. This results in a smooth operating brake application and assists to minimize brake chatter. Technicians today should consider installing automatic self-adjusting slack adjusters, particularly the Midland clearance sensitive unit that will not over-adjust. Automatics and manual slacks should not be mixed on the same vehicle. In fact, different makes of automatics should not be used on the same vehicle because each make has different methods of adjusting with varying tolerances. The last component in the primary circuit is the stop lamp switch, which we've already discussed. That wraps up our overview of the parts in the primary service circuit. Let's move to the parking circuit. The parking circuit's job is to control the application and release of the spring brake as a mechanical means of parking. This mechanical parking capability is also an alternate way to stop the vehicle in an emergency or loss of air condition. Since the parking and emergency circuits are actually one and the same, let's deal with them together. There are four basic devices in the parking circuit, three of which we've seen before. A two-way check valve, a yellow dash valve, a quick release valve, and the parking emergency side of the spring brakes. And there is one major device dedicated to the emergency circuit called an inversion valve. Let's begin with a two-way check valve that separates the primary and secondary service tanks. This two-way check allows one or both systems to supply the parking emergency circuit, ensuring that in the event of a single circuit failure, the parking emergency brakes could be released once. Law 121 mandates this safety capability to prevent a vehicle locking up on the highway in hazardous driving conditions. The yellow diamond-shaped dash valve allows the driver to apply and release the parking brakes from the driver's seat. The yellow knob pops out automatically when system air pressure drops below 40 psi and will retain enough air for a controlled stop. This on-off valve also serves as an emergency brake. The quick-release valve is needed in the emergency parking brake circuit to allow air in the spring chambers to be released quickly to apply the parking emergency brake. Remember, the spring brake assemblies have two sections, a service chamber that operates the service brake, and an emergency and parking section that contains a very strong coil spring that mechanically applies the parking or emergency brake. Use extreme caution when working with a spring brake. The spring in the brake is under great pressure, and if released improperly, it has enough force to go through a cement block wall, a very dangerous and deadly projectile. Do not attempt to service the spring brake side. It's too dangerous. Simply replace the entire unit. Checking for spring brake center seal leakage should be part of a periodic maintenance schedule by charging one side of the assembly and listening for leaks from the other. Also, be sure to keep the caging tool hole plugs in place to keep out the dirt, dust, salt spray, and other contaminants. Now let's take a look at the emergency circuit inversion valve. The valve is only operational in the event of a primary or rear brake failure. Its purpose is to sense the front brake application pressure and invert that pressure to release, which allows for the modulated application of the mechanical spring brake to assist the front brakes to stop the vehicle. This valve's function can be tested by draining the primary tank to zero. That completes the parking and emergency circuit. The next circuit we'll cover is the anti-compounding circuit. You will likely find a quick-release valve with a two-way check valve in this circuit. The anti-compounding circuit's job is to prohibit the application of the spring parking brake when the service brake is applied. If not prevented, the compounding of these two braking forces will damage the foundation brakes. A good example of how this might happen is when a driver is parking the truck. He may still have his foot on the foot valve at the same time he pulls the yellow knob on the dash valve to apply the parking brakes. In this event, the anti-compounding valve senses the foot valve's pressure and will not allow the parking brakes to apply as long as the service brake is applied. This action eliminates the compounding threat, which could cause bent chamber push rods, twisted S-cams, broken slack adjusters, damage to brake shoes, or even cracking of brake drums. When a truck becomes a tractor pulling a trailer, there's an additional circuit to be considered: the trailer supply and... When a truck becomes a tractor pulling a trailer, there's an additional circuit to be considered: the trailer supply and control circuit. The purpose of this circuit is to provide safe, compatible braking and parking for the trailer in combination with the tractor. So let's complete review of the air brake system circuits with a look at these components: trailer supply dash valve, tractor protection valve, two-way check valves, and a hand control valve. The trailer supply dash valve has a red octagonal knob and is used to supply the trailer. It is an on-off valve that usually gets its supply from the yellow dash valve. It too has a safety feature of popping off at about 40 psi to retain enough air to bring the vehicle to a safe and controlled stop in the event of an emergency loss of air. A tractor protection valve performs the function as its name implies, protecting the tractor's air system should there be a failure or breakaway in the trailer system. The red dash valve feeds the TP valve for a supply to the trailer systems, and the service brakes on the trailer are controlled by the signal from the foot valve, which passes through the TP valve. The last item for review is the hand control valve, which some drivers use to assist their braking effort. It is a modulating in-cab valve that controls the trailer brakes only. It requires a two-way check valve so that the trailer service brake control pressure can come from either the hand control valve or the foot control valve. This valve should not be used for parking. Well, that's a total air brake system. With this introduction to the operation of air brake systems and their components, you should be better equipped to maintain and service the big rigs.